At the outset, we have to know that the idea on which the steam engine was based was the beginning of our obtaining sustainable movement motors for fossil fuel motors, such as diesel, gasoline, and gas motors, even jet motors. Therefore, we must know how this was done for us. The era of steam began with the invention of the steam god, which provided humanity with the necessary energy and multiplied the speed of the path of progress many times, and eventually led to the era of the Industrial Revolution, scientific technology, and social changes. The Greeks of the Hellenistic stage knew the driving force of steam, and they knew the use of various metals, and they used levers, wheels, gears, and even cylinders and pistons were used in the pump used to fight fire. Let us ask the same question that world historians have asked themselves several times. But why didn't you build the steam engine at that time? The objective reason given by historians is the lack of iron and fuel in one place, but there is another circumstance that is no less important and fundamental. It is the wrong understanding of the sages of that time of the essence of the physical processes taking place. That the idea of the existence of water vapor never occurred to them. Rather, they believed, according to the teachings of Aristotle, that there are four elements, and that when water is heated, it turns into air. Water transformed by heat becomes air. The vapors rising from the heated crucibles are nothing but an expanding liquid that has become air as long as fire disintegrates and transforms every solid. In the year 1543, Sea Captain Blasco de Gary invented a steam-powered engine and installed it on a ship that made it move without sails at a speed of 2 km/h. He presented his invention to King Charles V, who rewarded him, but he ruled out the possibility of using this machine due to its huge and dangerous nature, because it is liable to explode and has high costs. The scientific revolution in the 16th and 17th centuries associated with the names of Copernicus, Galileo, Francis Bacon, Hilbert, and others had cut off the verbal restrictions of the Middle Ages. So experiment was introduced to science, the results of which proved the validity of the conclusion only. And new devices were established for the human mind to comprehend, by which the laws of nature. It is natural that scientists and engineers could not ignore the study of the properties of water vapor known to all for a long time. The physicist Gamma Bechdel-Port had invented in 1601 a special device to try to record how many parts of the steam, which was still called air at the time, could be transformed into one part. It is possible that his experiments led to explosions, as he mentioned the expression, the frightening force, in his book more than once. In 1615, a book was published in Frankfurt, Causes of the Driving Force, with various useful and entertaining stories, written by the French architect Solomon Decaux, who worked on preparing fountains in the villages of noble personalities. In this book, an invention of its author was described, in which he mentioned, "We can use the method of raising water with the help of fire mainly for different machines." Then follows a description of the fountain that Heron of Alexandria had previously taken. Water actually rose in this machine by the power of fire, but it was not a steam engine yet. In Rome in 1630, a modest young man named Ivan E. Best Torchli learned mathematical sciences. His teacher was Bento Castelli, a professor of mathematics at the University of Rome, and one of his students loved Galileo. Torchli invented a typical experiment that immortalized his name in its simplicity and clarity. He assumed that if the water was raised in the tube to a certain distance only, then if a liquid heavier than water was placed in the tube, it would rise to any distance less than the water, and that this difference must correspond to the relationship of the specific weight of the water, and for the chosen liquid he chose the world has the heaviest liquid, which is mercury, and it stopped at the level that the new theory accurately predicted. On December 19, 1648, Biro, a relative of Pascal, conducted an experiment from the Beaudouxum mountain, which confirmed the correctness of Torchli's view of atmospheric pressure. Years later, the mayor of Magdeburg Ottavon investigated the possibility of forming a vacuum by experimenting with two hemispheres attached to one another. strongly as a result of emptying the air between them so that 24 horses could not separate them from each other, but as soon as the air cock was opened and entered and the pressure equalized, they separated easily. This experience led to the proposal of Jean Gonville Parisian mechanisms in 1678 to create a god. If a little gunpowder is burned under its piston, the expanding hot air will raise the piston to the top. Then the atmospheric pressure will return the piston to the bottom after the hot gases have cooled. In other words, it was a clever conception of creating an internal combustion engine that is the prototype for modern car engines and others later. James Watt and his steam engine. In 1782, James Watt obtained a patent for the steam engine, and thus all the inventions needed to build the steam engine were completed. In 1782, the steam engine ran a grain mill in Kettle, and the number of machines established in English factories began to increase significantly. Businessmen immediately realized all the benefits of using steam power and realized that the means of rapidly increasing the productivity of labor are in their hands. The developing industry was liberated from the necessity of its presence near the rivers, and during the first 10 years after the invention of the machine. From 1775 to 1785, 66 machines were installed in various institutions, and in the next 10 years 144 machines, in addition to 47 of them in the textile factories. And after a quarter of a century, there were 1,500 steam machines in England alone. 180,000 horsepower. The European continent did not want to lag behind the workshop of the world, and steam machines were manufactured in France, Germany, Belgium, and Sweden. Then they began in the American states, and in 1729 the first steam machine was established after the Bolesnov engine in the Urals, Prussia. The steam engine proved to be a very effective invention so that it had no enemies, and found use in various fields, and its inventor James Watt deserved international glory also, and was elected in 1774 a member of the Edinburgh Royal Society, and in 1775 a member of the London Royal Society, and in 1806 awarded the University of Glasgow, which Watt started his activity mechanically in her workshop, and worked on educating himself by himself, which gave him the honorary title, Doctor of Sciences, and the Parisian Academy of Sciences elected him in 1824 as one of its 8 foreign members. With the invention of the steam engine, man learned to convert the latent heat in the coal, the tree, and the charcoal into movement and work. In practice, he put the energy of the sun, or the furnace, as the ancient Egyptians called it, at his service, and its energy that overflows on the earth with successive continuous flows that were stored in fossil fuels of all kinds. Coal, oil, wood, gas, etc. It seemed that humanity was able to achieve the most daring projects. The steam engine was one of the breakthroughs in the history of inventions that changed the face of the world sharply. Revolutionized industry and means of transportation, enabled the construction of huge projects, and provided an impetus for a new launch of scientific knowledge. This invention changed the society itself and the social relations in it as well. So it was a symbol of the Industrial Revolution and was a precursor to social revolutions. Watt's invention also led to the culmination of the works of engineers and mechanics over many centuries in various countries. Those works that sought to curb the mighty power of steam and put it in the service of man. The inventor's attempts to capture the origins of the new form of energy varied, and they contributed to finding the final solution to countless emerging problems. However, each of them stimulated solution research, summoned supporters, and raised students who followed the work of their teachers. For the sake of transportation, it required the development and use of machines in which the piston moves not at the expense of atmospheric pressure, but rather by the power of steam. In 1802, these machines began to be made in the United States of America, led by inventor Oliver Evans. Born in 1775 in Philadelphia. Like most other inventors, he could not get a regular education in childhood, with he showed great talent. when he read that the inventors of the steam engine used steam to obtain the vacuum only, neglecting the enormous power of compressed steam. Evans searched for many years for a way to apply it until he built in 1801 the first working model of the high-pressure steam engine in England and obtained a patent for it in 1802. High-pressure machines were much smaller and lighter than Watt machines, and they could be used to solve transportation problems. In fact, high-pressure machines required much more powerful and accurate boilers and cylinders. However, this was a problem that had become old. The machinery construction industry had developed at the beginning of the 19th century to a sufficient degree and was able to meet the new requirements. The first successful experience of building a steam locomotive goes back to Dr. Trevithick, an Englishman, where the experiments took place. In 1803. At that time, young George Stephenson learned and led the steam machines, who learned to read and write in a private evening school in a mine near Newcastle. His life began with great difficulty, as his father served in the mines. His mother died when he was 3, and he did not get an education. And as soon as he grew up a little, he helped his father. After that, he worked in the mines as an expert in the use of various mechanisms and attempts to understand them in detail. And soon he became a recognized and specialized mechanic. George was interested in commercial transportation, and in 1814, when he was 33 years old, he tried his first locomotive, and it turned out that the design was unsuccessful. In 1825, 16 steam locomotives were built and became significant. Then his son Robert George Stephenson became his assistant. The father's practical acumen was completed with the wonderful culture of the son. Until the middle of the 9th century, steam occupied the place of other sources of energy such as winds and water courses, which were replaced by the power of steam, thus increasing the capabilities of humanity in the use of energy in a way that was not previously known. Evolution. In fact, the unexpected obstacle for mechanics and inventors to develop machines was the absence of the theory of steam machines and the incompleteness of the theory of heat in general. And there were no calculations showing the mathematical and physical relationships between the forces used in these machines. In addition to that, in fact, the properties of water vapor were not known in that time. And now we will talk about the beginning of the development of science and its impact on the use of energy. And the discovery and development of more movement motors, starting with engines operating on oil derivatives, such as the Otto engine and the diesel engine, then the emergence of the turbine, jet, missile, and rotary engines. We will explain the details of the work of each of them and ways to develop some of them to suit the new fuel types that are currently being worked on. And this is in the upcoming videos.